So we've been talking about matter and what it makes up and everything to do with matter. So now it's time to focus on physical and chemical properties of matter. And today we're going to cover the physical properties. So, physical properties can be observed without changing the matter's identity, without changing what makes it up. So, matter can have color, shape, odor, volume, texture, and asking questions about physical properties can help you identify it. We have 6 physical properties of matter that we're going to focus on in this class. So, thermal conductivity. Thermal is another word for heat. So, can it conduct heat? So think about why you wouldn't put hot coffee in a metal cup, and instead you would put it in a styrofoam cup or something that wouldn't conduct heat as much as a metal would. So state, changes of state is a physical property, and we need to make sure that when we are looking at ice as it's melting, that we're not mistaking that as a chemical change. Changes of state are physical properties of matter. And density, we learned about density a little while ago, density being mass per unit of volume, and figuring out how dense a substance is another classifying physical property. We have solubility. This is a new vocabulary word. So, the ability of a substance to dissolve in another substance. Think about making Kool-Aid. When you pour the Kool-Aid powder in the water, what does it do? It dissolves in the water. The Kool-Aid is soluble. So solubility is a physical property. We don't have a chemical change happening there. That's strictly physical. And ductility, another new vocabulary word. Ductility means being able to be pulled into a wire. And the best example that I can give for this would be copper wiring. And malleability. Malleability, another new vocabulary word. Malleability is the ability to be rolled into a thin sheet. And one of the most common examples that I give for this is aluminum foil or aluminum. Aluminum can be pounded out into that tiny thin sheet, and we use it for aluminum foil. So, density, just a review of what density is. It's a physical property that describes the relationship between mass and volume, because density equals mass divided by volume. And it's the amount of matter in a given space. So, think about a golf ball and a tennis ball. They kind of have similar shapes, similar volumes, but their masses are very different. Because the golf ball has more mass than a tennis ball, the golf ball is actually going to be more dense than the tennis ball. And if you think about oil and water, when you mix them together, which one floats? Probably the oil. The oil is going to float on top of that water. And that's because oil is less dense than water. Okay, when we're looking at density of a solids, would you rather carry around a kilogram of feathers or a kilogram of lead? It's a trick question. Most people are going to respond the feathers because they think that feathers are lighter. But if we're looking at a kilogram of them, they're actually going to have the same mass. But you would actually have to have a lot more feathers because they're less dense. You need a lot more feathers to equal the same mass of lead because lead is more dense. So it'd probably be easier to carry around the lead, right? Because you'd have to have a big sack of feathers to equal 1 kilogram of feathers. So knowing the density of a substance can tell you if the substance will sink or float. Just a fun little fact, the density of water is 1. And if you have something that's less than 1, so let's go back to the oil and water example. Oil is less dense than water, so oil has to have a density less than 1 to float. If we had something that was greater than 1, let's say we put a rock in that water, a rock's density is probably going to be greater than 1, so it's actually going to sink. So, if we're solving for density, we learned that the equation for density was D equals M divided by V, right here. D equals density, mass is the M. V stands for volume, so D equals mass divided by volume. So we have some different variations of density units. We can see it represented as grams per centimeters cubed, grams per milliliter, kilograms per meters cubed, or kilograms per liter. So if you see these are all going to represent density. So if we use density to identify substances, most substances have different densities, and we can use it as a classifying property. So here's just a little table that I put together for you to just compare some densities. The density of helium is much less than the density of mercury. So just comparing different solids or gases, densities of different things, you can know things about those substances. And we have to be able to manipulate the density equation. Sometimes it'll ask you to solve for the mass, or it will ask you to solve for the volume. And it can get kind of tricky when it gets into those kinds of problems. So we know already that the equation for density is D equals M divided by V. Density equals mass divided by volume. Some ways that we can manipulate that is if we have to solve for either mass or volume. If we have to solve for mass, we can set up the equation this way. We can say that mass equals density times volume. Okay, so that will give us an opportunity to solve for mass if it doesn't give it to us in a problem. We can also solve for volume by manipulating the same equation that we started with, and we can say that volume equals mass divided by density. These are three different ways that we can use the density equation. So, if we are thinking about physical changes, we need to know that they do not form new substances. Physical changes do not form new substances. They just affect the physical properties of a substance. So, let's say if you're wearing a necklace. I have a necklace on right now. It's in the shape of a heart, okay? Just because it was pounded out into the shape of a heart doesn't mean that it's changed the metal in any way. It's just being formed or shaped. It's changing the physical properties. It didn't make anything new. And the identity of the matter isn't involved. So, the example that I have here, if you melt a stick of butter, is it still butter when it's melted? Yes, it is. It didn't change the matter's identity. It didn't make anything new. Melted butter is the same as a stick of butter. So nothing's changed, nothing's new. So, changing from a solid to a liquid is a physical change. It's a physical property. Changes of state are physical properties. If you crush an aluminum can, did we form anything new? No, we didn't. It's a physical property. And freezing water, again, that's a change of state. What about sanding a piece of wood? That's kind of hard because those little tiny bits of sawdust don't look like the wood that we started with. They look like something new, but sawdust is actually still wood. So it's a physical change, a physical property. And dissolving sugar in water, going back to the example of solubility with the Kool-Aid, that's a physical property, a physical change.